Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for choosing IT Pro TV, helping you learn wherever you go. I'm your host, Zach Memis, and this is A+ 901. This is exciting, and we're diving into configured BIOS and UEFI settings with our very own Wes Bryan, who knows more than me.
Hey, Zach, how you doing? That's
well.
right. We're going to be looking right at configuring our BIOS and UEFI settings. And I know what you're probably saying if you're getting into the A+ for the first time. What is this alphabet soup that they are feeding us right here at the beginning? But let's go ahead and let's define what BIOS and UEFI is, and then we'll take a look at some of the settings that you can configure. Now, BIOS is a basic input-output system, and UEFI is the Unified Extensible Firmware Interface. Now, why would we need something like BIOS? Well, in the earlier days of computing, going into probably the later 70s, when hobbyists were bringing out of the, like for instance, universities and these big like Sun Microsystems, you wanted to be able to have your own small computer. But the problem was, in order to make that computer work, you had to have programming, right? And the programmers, when they developed the software, they also had to have a good innate understanding of what the hardware was. And they had to program each individual little piece to allow their software to control their hardware, because imagine what an operating system is. That's basically what it does. It allows us to control our hardware. Now, the problem with that is every system that would come out, your programmers would have to know all about the hardware in order to get the machine started and brought up online. So what BIOS does is it allows us an independent, a system independent, if you will, way to get our hardware started, get it stabilized, so that when the operating system loads, it doesn't have to worry about any of that. The hardware's ready to go, it's online, and then BIOS or UEFI, they can transition and let the operating system take over after that. It also means that the software programmers who are designing the operating systems to control the hardware, they don't have to know in depth what the hardware is. What they have to do is they have to make sure that their operating system can take over after BIOS does. And BIOS is something that's going to be controlled by the manufacturer of the hardware. So it makes it really good. Hardware manufacturers can focus on things like the BIOS and UEFI, and the operating system developers, they can work on their operating system. So what's the difference between BIOS and UEFI? Well, there's a lot of difference in them, but basically they're doing the same thing. See, BIOS was written back in the late 70s when we had 8-bit systems. It's really an outdated way to start your hardware, bring it online, and get it stabilized. It also has some limitations, right? So later down the road, Intel came out with what is known as EFI, the Extensible Firmware Interface. Well, Intel wanted this to eventually become a standard that everybody could use. So what they did is they tried to distinguish their earlier EFI from something known as UEFI. They basically handed the standard over to the public. And in order to differentiate from the earlier Intel-based EFI, they called it the Universal Extensible Firmware Interface. Now, these interfaces, they're doing the same thing. They're called firmware. And again, basically understand that firmware is a way that we can bring our hardware online, get it stabilized, make sure that the checks are in place in order to get the operating system loaded, and then the operating system doesn't have to worry about that. So that's a little bit about our BIOS, basic input-output systems. What happens is we send a little bit of input to different components within the system unit, and if those components respond back, we get a message back from them that we know that they're there, present, and ready to go. So that's a little bit about BIOS, and again, keep in mind Unified Extensible Firmware Interface, pretty much doing the same thing, but the difference is it's the more modern version of BIOS.
So what is some of the information that we can actually see in the BIOS?
There's a lot of great, that's a good question, a lot of great information that we can see. In fact, let's go ahead and check it out. I've got a BIOS pulled up here, and this is, you will see, this is actually a Unified Extensible Firmware Interface based system. However, don't let that bother you, because every vendor's a little bit different, but when it comes down to it, a lot of the components that you see will look alike. The interface might change a little bit in colors and how you interact with it, but for the most part, you're going to see just about the same information. Now, some of the basic component information that we can look at is under, for instance, in this BIOS is under General. you can see that we see, well, system information, right? Well, what is system information for us? Well, if you notice, you can see things like the BIOS version. That's going to be important. Well, why is that important? Well, you have what are known as firmware updates, and when we update firmware, a lot of times what it does is it fixes some kind of functionality flaw. It can sometimes even give you more functionality by adding a couple of things. So it is important to understand what the version of the BIOS is, so as the manufacturer of the hardware releases new firmware platforms, or updates if you will, you can tell whether you've got the most current. Now I do want to warn you real quick, when we talk about the system components and we talk about updating your firmware, it's also called flashing the BIOS. See, when you think about BIOS, BIOS is something that sits in a type of memory that's non-volatile. And if you're not familiar with non-volatile memory, go over and check out some of our memory episodes, if you will. Remember, non-volatile memory just means that I don't need an electrical current to keep refreshing that information to retain it. It also means when I turn the power off, all of that data that's stored in it is going to stay. It's going to stay there. It's not going to be lost. All right. Now here's the thing: with flashing that non-volatile memory, you have to make sure that it's never interrupted, because if there's, let's say, an electrical storm, if you pull the power during a firmware upgrade, you could cause irreversible damage that could damage the unit so much that, well, unfortunately, you might have to replace the entire motherboard. So be careful when you're flashing BIOS. You can see other information here too. You can see information, for instance, about halfway down, you can see things like the RAM, right? Our random access memory, our system memory. And I can see, for instance, inside of this BIOS system information, or UEFI system information, I can see how much is installed. I can see what the bus speed is. You can see 1600 megahertz. I can see what channel it is. I can also see what technology it is. This type of BIOS here gives us a lot of good information. I can see that it's DDR3 RAM, so it's relatively new. And even more so, I can see where the RAM sticks are installed. I can see that I have, for instance, 3 and 4 on our motherboard. They're not even populated. They don't even have RAM sticks in them. So you can see things like that, right? We can see, for instance, also things like, for instance, hard drive information. You can see, as well, things like your expansion slots. But you could have the ability to control other things like optical drives and even CPU information. Now, we've got some different things that we can configure inside of our BIOS. Some of those things that we can configure are things like, for instance, our boot sequence. Now, boot sequence is important, right? When we look at our boot sequence, this says, where does BIOS look for the boot record to basically bootstrap the operating system, right? To bring the operating system online. And boot sequence is important. A lot of times you'll see that the boot sequence will start with things like your optical drive first, then it'll go to things like, for instance, maybe a USB device as well. You can also see sometimes it might go to an external device. It could go to things like your onboard network interface card, which again is your network basically booting from the network, finding an operating system stored out there on the network. And then last, a lot of times last in the boot list is the hard drive. So boot sequence is very, very important inside of your operating system, or inside of your BIOS, because it tells the BIOS, the basic input-output system, or UEFI, where do I look for this operating system? And more so, where do I find the little record that allows me to bootstrap that operating system, so that the operating system, once BIOS is done, can start to take over the hardware. All right. Now, there's other things that we can do inside of the configurations in BIOS. We can do things like enabling and disabling devices. And if we look down through here, you can see different things as well, right? For instance, if I get down to system configuration, I can see that I can do different things with our integrated network interface card. That's a network adapter. That's what allows us to communicate across the network. And I can do, and you can see over here on the other side that I can enable the UEFI stack. I can disable it. If I don't want it to be turned on during the time of boot, I just disable it. I can also enable something known as Pixie Boot. And we'll get into Pixie Boot a little bit later, but this is the pre-execution environment, and that's part of the process that allows me to call out to the network and say, hey, you got an operating system out there? Because I need one. So it's just another place that our BIOS can look when it needs to bootstrap the operating system.
And date and time is very important. How do we set date and time?
Well, that's a great question. Yes, date and time is very important because you have to remember that your operating system works on a timer. It works on a heartbeat, a clock, right? So everything has to be synchronized. And system date and time can also be modified here inside of the BIOS. Let me show you what I mean here. So inside of our configurations, that's actually under the general location. If I kind of scroll back up, you can see that I can set system date and time. Now, one of the things that I want to keep in mind that runs complementary, and you're going to see that it actually kind of comes up in the name, that complementary to BIOS, all right? Remember I told you BIOS information, that is stored in a non-volatile chip? It basically is the manufacturer's definition of how to get the hardware turned online. However, sometimes you need to make modifications to that. Well, in order to make modifications to this BIOS or this non-volatile RAM, what we have to do is that flashing process, right? And if I wanted to come in here and change settings, it wouldn't be feasible to flash the BIOS every time we need to make a minor configuration. So you have another region of volatile memory, very low voltage volatile memory that actually stores that information that you can configure, those settings that you can configure, and that's something known as CMOS. That's the complementary metal oxide semiconductor. And again, I know it sounds like a lot of jargon here, but it's just a little, volatile memory region that we have a little 3-volt battery that keeps that information refreshed so that when I come in here and I make my changes, it will store those user-defined settings. One of the telltale signs that the battery that provides the power, if you will, to that BIOS is losing, or excuse me, provides the power to the CMOS is no longer providing that power is when you come in here maybe to your BIOS and you notice that your system in date and time keeps refreshing maybe to a few years earlier, and what's happening here is essentially the CMOS is no longer storing your user-defined settings and you have to replace the CMOS battery. So system date and time is very, very important, and it is important to make sure that it is correct. And one of the telltale signs that you need to replace that battery on CMOS is when you set the time, you reboot the computer, and the time is reverted back to an earlier date and time. All right, so some other things that we might be able to set inside of your BIOS, maybe you could set this, sometimes you don't get the chance to, is what's known as your clock speeds. All right, clock speeds, when you enter your BIOS setup, please understand that every vendor is different. Some of the gaming boards allow you to set different timings on your clock speeds, if you will, or increase the clock speed, and it's usually done in a multiplier. Now, they're not going to ask you to calculate multipliers on the A+ exam, just understanding that what it does, and you can also hear it called a front side bus multiplier, it allows you to increase the clock speed. All right, imagine being able to hit the gas on the engine. What does it do? It revs the engine up, it makes the engine in a car go faster. Well, that's essentially what increasing the clock speed does. But I warn you, be careful on this, because when you increase the clock speed, essentially what you're doing is you're applying more voltage to it. When you're applying more voltage to a CPU, you run the risk of causing other components to fail or causing damage to the motherboard just because, again, you're increasing the voltage to the CPU. One of the things that you want to do is if you do increase the clock speed, you have to check the CPU voltage. And I said CPU, let's go ahead and define that acronym too. So I get so used to saying these acronyms. That's the central processing unit, right? That's the brains of the operation that is calculating all the information.
Like in Tron, the big head.
Yes, exactly. And what we can do is we can increase the computational power of the machine by hitting it with some more voltage. But again, make sure that the CPU voltage is set to match whatever the clock speed is if you do increase it. Again, the other thing too is when you increase the clock speed, you're increasing the voltage. So you have to make sure that you have enough voltage to match whatever you're going to increase, the clock speed on. Sometimes, sometimes it is something that you can do. Sometimes you can't set them at all. I know some of the gaming boards where gamers like to squeeze every bit of performance out of their machine that they can, spend a lot of money doing that, will do this, but in some of the basic systems, like this system that I have here, you can increase the clock speed. There's minor variations that you can do, but this is a vendor-specific technology, like for instance, rapid speed and stuff technologies. But again, just check with your manufacturer. Now let's go ahead and look at some of the other settings that we can see inside a BIOS. And again, I'm giving you an example of one here that is specific to an Optiplex 960, I believe. It's a Dell Optiplex. So what you have in your system might differ a little bit, but for the most part, you're going to see a lot of the same things that, that you'll see inside of this BIOS. All right. For instance, old serial ports, the COM ports, communication ports, a lot of times we don't even use these today because this goes back to the old serial-based interfaces, largely been replaced today by the universal serial bus, USB, and things like FireWire and stuff. So you can set these, but keep in mind, these are really becoming more of an outdated technology. We could do things like our serial ATA operations, again, doing things like the advanced host configuration interface, which we'll talk a little bit more in our storage section, so don't let that confuse you right now. We will come back to it. And we can set it back to a legacy mode too, like the ATA modes, and that goes back to the advanced technology attachments. And again, don't let those acronyms worry you right now, because when we get into our storage section where we define storage technologies, I'll be definitely make sure that we bring you up to speed on those. Now the hard drives, that's another thing in the BIOS information that we can see. But we can also do some configurations here. And this goes back to the CMOS that we were talking about when we talk about complementary metal oxide semiconductor. Boy, they can't say that 10 times fast. Is that when I get a system, when a system is brought in, let's say I bought it from the vendor, it might have a single hard drive in it, right? It might not have 4 hard drives, which you can see this one does take 4 hard drives. You can see SATA 0, SATA 1, SATA 2, SATA 3. That's essentially 4 different hard drives. But you might get a system when the configuration comes from the manufacturer that only has a single hard drive. So what happens? We end up, what happens is I apparently hit the wrong button. You can see that I can actually turn these interfaces off, all right? And I'm not going to go ahead and turn these off, but I could. But I can also turn them on. Now understand, when I got this system from the vendor, maybe it had 1 hard drive in it and all 3 of the other interfaces were turned off, all right? Well, when I put it in and install another hard drive and I turn that interface on, where are those settings going to be? Those settings are going to be stored in CMOS, right? Because what comes from the manufacturer by itself is stored in basic input-output system, or UEFI. Now, there are some other things that we can do in here, too. If we're doing things like, for instance, keeping an eye on our hard drives. Let me see if I can get out of here. There we go. You can see things like smart operations, which we'll talk about in another episode as well, just basically being able to monitor your hard drives for any kind of errors that might be happening. You can see USB configuration, right? Now, USB configuration, this can vary because, again, we have some older technology, newer technology here. We have 2.0, which is an earlier standard, and 3.0 that this supports. Again, you can see things like, for instance, rear and right and left and dual. So we can configure which one of those interfaces, those USB ports that you would plug a drive into, would be on or turned off. We can also do things like configuring the audio settings as well, all right? This disables or enables, as you can see on the screen, the integrated audio controller, right? Now, integration, let's talk just a second about that when it comes to our BIOS. Integration means, or integrated means, it is built into the functionality of the motherboard. It means all the little chips that we talk about in our motherboard episode, they understand how to control audio. All right, can you get a better sound if you have a non-integrated audio board? Yes, you can. We put it in expansion cards and we get expanded functionality. However, if we are going to go that route, we can't have 2 audio systems trying to control the operating system's audio system, right? They don't play nice together. So I'd have to turn one off. In this case, I would turn off the integrated audio. However, if I don't have an expansion card and I just don't have the money or whatever, don't have the resources, it's nice to have that functionality built into the capabilities of the motherboard. And what BIOS is going to do is when it's enabled, it's going to wake up and it's going to stabilize the audio subsystem. Again, send some components, send a few signals out and say, hey, audio, are you out there? Remember, input-output system, and then it's going to get some output back that the audio says, yes, I'm here, I'm good, I'm stabilized, I'm ready to go. Now, you can also see some other devices here, too, like they talk about miscellaneous devices. This is the PCI slot. That's the peripheral component interconnect. Now, and we talk about that as well in our expansion card section, too. So this is telling me do I want to have the PCI? Do I want to have PCI on or off, right? And in this case, we've got it turned on. Now we can go through some other things here in BIOS too, because one of the things that the BIOS does is it sends a little signal out to the video subsystem if it is integrated. If it's integrated, then the video subsystem will call back to BIOS and say, hey, I'm here, I'm stabilized, I'm good, we're ready to go. Go on with your input-output system. Check the next device. However, if you have an audio card in an expansion slot, right, a slot on the motherboard gives you better functionality. A lot of times those video cards, they have their own BIOS built right into the card. And then what the master BIOS, in this case, what we're looking at here does is says, okay, I'm not going to take control of that. You go ahead, video card. You just let me know that you're ready to go. And that it sends back, it still communicates with the master BIOS, but it has all the hardware on it that it can stabilize itself. Now, just like our audio, we have to understand that if we have an onboard video system, we have to have one turned on and one turned off. All right, you don't need it turned off if you don't have a graphics card sitting in that expansion slot. If you do have that graphics card sitting in that expansion slot, then you're going to have to make sure that you turn this off. So the BIOS doesn't look to and call on that system as a part of its routine. All right. So those are a couple of things that we can do inside of our BIOS. But we've got some more things that we're going to look at coming up.
Now, Wes, I understand security would be important in the BIOS.
It definitely is. And some of the things that we need to keep in mind is like, for instance, we can tell sometimes when people actually get into the system, which is kind of cool. I will tell you, as you're going on in your security training, remember, if somebody's got physical access to your device, security really needs to be beefed up, but at least they give us a way to see certain types of things and also to secure different things inside of the BIOS. In fact, let me go ahead and show you what I mean here. You'll see in this one we do have some security settings here. If I go ahead and what I do is I expand them out, we've got quite a few things that we can do. For instance, we can set an administrative password. Now, an administrative password is interesting now because what an administrative password does is it essentially allows people the ability to configure the BIOS. But you can also have, for instance, a system password. And again, the system password means that you're allowed to not only boot BIOS, but you're allowed to now boot the operating system. Now, guys and gals out there, don't confuse this with an operating system password. After we booted everything, the operating system is showing you a logon screen. That is a separate password altogether. What this really says is, are you even allowed to get to the point where you can boot the operating system? So, a couple of good things, right? So if you set a system password, right, what that does is it gives you the ability to just continue the booting process, but it doesn't allow you to actually get in here and configure these settings that you see in front of you. The administrative password, what it allows somebody to do is get in and make changes to the BIOS. Now, we can go a little bit farther than that. For instance, if the device has things like drive encryption, you can do a full drive. You can require drive encryption in your BIOS as well, which will do a hard drive encryption, just like it sounds, basically scrambling your data so that if it is taken out of this device and maybe put into another device, you won't be able to read the data. We can do other things too. You'll see, in fact, in here there is something known as TPM security, and we can turn that on or off. All right. Now, what is the TPM? But the TPM essentially is something known as a trusted platform module. All right, now that sounds like it is a highly technical type technology there, but really all it is it's a little chip that sits in the motherboard and it stores security information. And it also works with another technology that we have called Secure Boot. Now, Secure Boot is part of the Unified Extensible Firmware Interface platform. It is not a part of BIOS. This is one of the advantages of moving to the modern UEFI system. Secure Boot, what this does is this says, if we don't have trusted bootloaders stored in that trusted platform module, remember I told you it stores security configuration information, then it won't allow the operating system to even bootstrap itself. All right, so a very good thing to have. Secure Boot is something that will lock down your system if, let's say, for instance, a bootloader virus tries to bootstrap the operating system and inject a rootkit. What Secure Boot says is, hey, I see something trying to take over the hardware here, which is what an operating system does, but what I'm not seeing is that information that identifies it as trusted down in that little processor, that little TPM, that trusted platform module. Now the level of what you can configure here is really based on, you know, the vendor themselves. Now the other thing that we have is something known as LoJack.
So are we talking about tracking your car if your car gets stolen here? Or
You know, that's interesting, Zach, that you say that, because the technology is really the same, right? LoJack, it was, in fact, if we can bring back up the screen, it's interesting because this one still has CompuTrace. Now on the exam, ladies and gentlemen out there, they call out LoJack, right? This was the earlier name of CompuTrace. They changed it to LoJack, but all it means is it's a way of tracing your computer. And I'll give you a little story here. Several years back, there was a guy that did some social engineering attack, and he went into a company dressed in I don't know what you call them, the suits or whatever, you know, like a jumpsuit, right? And he looked like he was a technician, and he said, hey, I'm a technician here, and I'm here to work on such and such machine. Well, what they didn't notice is the cart that he brought in, he was actually stealing people's laptops, and he was putting them on the cart, and he walked right out of the building with a whole bunch of laptops. Well, he stole the wrong laptop because one of these had CompuTrace or LoJack on it, and the authorities were able to track it down to its location. So it's a very, very good thing to have. And if you do have it within your system, especially things like laptops, I would definitely recommend turning it on, because it's a way that if your device does get stolen, kind of like you said with the cars and stuff, that you can, hopefully, you can bring it back into your possession, or if nothing else, you can do what's known as a remote wipe. Any data that's on the system from a remote location, you can essentially issue a command that says all the data that's on the hard drive, eradicate it, just erase it completely. So a nice thing to have when it comes to your security and securing your systems. Now, I also mentioned some of the things that you can do too is things like chassis intrusion or intrusion detection, and this just basically means that if the case is opened up, right, and that means somebody's going to try to get in and gain physical access to the machine. Once they close it, next time you boot the machine, it's going to let you know. BIOS is going to do what it does. You'll see when BIOS boots up, a lot of times what you see is a little bit of low diagnostic tests. That's actually the first part of BIOS. BIOS has what's known as power on self-test. And the power on self-test basically is what's sending out a little electrical signal saying, hey, if I send power to you, can you report back to me, right? And once you report back to me, I know that you're present, and then BIOS starts to basically turn on all the hardware. Well, as part of that post process, if the chassis has been opened, the tower, the case of the machine, you're going to be made aware of it. It's going to be a little low-level text, real low-resolution text that comes across the screen that says intrusion detected. So that's a great thing to know if anybody has tried to make some physical access. Now, keep in mind, it doesn't stop them if they do make access into the device itself, but it at least will make you aware of it. So whether that's there or not, again, I will tell you, is really contingent on your device.
What's virtualization support? What is that?
Virtualization. Now that's another thing that's really, really handy today, and it's another thing that has become very, very popular inside of our PCs, and not only PCs but Macs, if you will. And virtualization software is where you can essentially run more than one operating system on within a single CPU, within a single PC or system unit. In the earlier days, if we wanted to have more than one operating system, then what we would do is we would do something known as a dual boot or a multi-boot. Now, understand that when you do a multi-boot, you have one operating system boots up, it takes control of the hardware, and we work with that operating system. Now, to get into the second operating system in a multi-boot situation, we have to shut the first operating system down, and we have to launch the second operating system. When you talk about virtualization, if your CPU supports it, that means that we can run more than one instance of an operating system simultaneously on a single physical device, which is really great for things like testing purposes. But you have to make sure that your BIOS supports it. Most of the modern systems do support your BIOS. In fact, Intel has their Intel VT, and then AMD-based systems have AMD V, which is AMD virtualization. Let me show you here, because sometimes you have to enable it. Sometimes, in fact, let me go ahead and I'll close some of these off here and make it a little bit easier to move around. You can see that this one does have a virtualization option. It says virtualization virtualization support. And when we get into here, notice this is an Intel-based system because you can see the VT, so it's Intel VT, if you will. But notice that virtualization is turned on, right? And you can see virtualization technology. Again, AMD has their flavor of it. It's AMD V. And again, sometimes you have to enable it, sometimes you have to disable it. But make sure that if you're going to try to implement some kind of virtualization where you want to run more than one operating system on a single device, make sure that you check whether that virtualization is turned on or not. All right, so some of the other things that we might be able to do. I mentioned SMART, all right. SMART is a technology, again, we'll talk about it a little bit more in our hard drive technologies that allows you to do things like diagnostics. Sometimes there are built-in diagnostics, sometimes there are not, all right. So if we look at our system here, we can see that there are some maintenance things that we can do. So for instance, service tags, and where is system logs here? Power management. All right, so sometimes you have system diagnostics, sometimes you don't. The example of one, again, is like that SMART technology that you have. Power management as well, and I'm not really seeing any, in this one, any specific, no, I'm not really seeing any system diagnostics that we can do here, but we can log different types of events as well. The level of diagnostics that you can do is really contingent, again, on the BIOS that you have. For instance, in some of the systems that you have, you can monitor things like your fan speeds, again, intrusion detection we've talked about with notifications. You can monitor the voltage, right? I said if you're going to increase the CPU clock speed, well, you need to monitor the voltage because that's what you're doing. You're ramping up the voltage that you're sending into the CPU to make that engine run a little bit faster. So sometimes you can monitor this as well. A lot of times you can monitor the bus speed and see where the bus speed is at. You can also have things like third-party software that can do this too. But what's interesting is in some of these systems, you can also do thermal temperature monitoring too. For instance, these 960s here, and I know the earlier 940s, I believe they were, and 745s, would have things like little thermal temperature sensors, and they would plug into the motherboard, and they would snake their way around to the front of the case, and what they would do is they would monitor the overall temperature of the system, making sure that it's within the adequate means. Because remember, two of the major things, one of the major components or causes, if you will, of component failure is improper thermal management, basically overheating. So it is important that we do make sure that we are monitoring that. Sometimes you have that built into the case where the actual tower can do this as well. Sometimes you can see that we have this, again, built into the BIOS, that it will show you what the current core temperature is of the CPU, what the core temperature, not the core temperature, but what the temperature of the system unit is as well. Because keep in mind, as our CPUs heat up, right, the hotter they get, the more likely they are to become damaged. And really, when it comes to thermal damage, a lot of times you don't actually see it. It usually manifests itself in kind of erratic behavior, and it can be very hard to detect. So that's why it's good to have some kind of temperature monitoring system. Now, if you don't have that in your BIOS, don't worry about that, because you do have software that you can get and you can install on your machine that can do this from inside of the operating system too. Now, the other thing is, if you're fans, right, you have things like CPU fans that help to actively cool the CPU. If you are plugging CPU fans, they plug to the motherboard, but sometimes you have system fans as well that plug into the motherboard. And one of the things that you can do with monitoring is you can actually monitor what the fan speed is, how many RPMs it is. So for instance, if you increase the voltage to the CPU and you increase the power to the system, a lot of times what you'll have is fans that are controlled by the motherboard, and they're variable speed fans, and they'll put more electrical current going into the fan to speed up the RPMs. And that's why it's good in these, when you have monitoring like this, because you can see as the fans ramp up, is it bringing down the temperature, the internal temperature of the system? You might find that it's ramping the system fans up to a high RPM, and you're not noticing anything going down in the temperature of the machine. That could be a telltale sign that maybe either your fan's failing, or it could be just that the fan's not adequate for the system, and that does happen. And that's why, I mentioned earlier, Zach, that a caution, when you're increasing the CPU voltage like that, sometimes you might hear that called overclocking as well. Yes, you could get a better performance, but you have to know that there are checks and balances that you have to implement. If I increase voltage, I increase power. If I increase both of those, I increase temperature. So I might have to increase the cooling unit that we have inside of the system. And we'll talk about cooling units in another episode. But however, know what the basic output system is. Know that we go through things like the power on self-test, right? Post, as it's called. Send out a little electrical signals. We check on those devices, make sure that they are present. BIOS helps us to finish the process by stabilizing all of those devices. And then finally, looking for a master boot record to bootstrap the operating system, allow the operating system to take over, and in the end, it's your hardware manufacturers that have to worry about the basic input-output system and not your operating system vendors.
Fantastic job as usual, Wes. Configure BIOS and UEFI settings. Marvelously done. And A+ 901, there's more in this series. At IT Pro TV, we are committed to helping you learn wherever you go. And you know, a good IT pro is always learning. I'm Zach Memis.
And I'm Wes Bryan.
And we'll see you soon.
Thank you for watching IT Pro TV.